All right, let's take a look at this here and see where we're at. I sampled a couple of problems for you, and then I said try these other ones. So I've tried the other ones, and I'm going to replace my m, my x, and my y. You can see I'm using the substitution property there. So replacing all of those, doing my arithmetic, I solve for b, and now to answer the question, it fills in the formula y equals mx plus b. Replace my slope with the -3, my m with -3, and my b with 4. Pretty straightforward. Given a slope, given a point, I should be able to write the equation of a line. Flipping the page over here, I gave you a similar problem, but maybe not quite so nice because I didn't give you the slope. I did, but I didn't. I gave you 2 points, which means you can calculate the slope. So I'm going to use my calculating slope formula, which is my change in y over my change in x. So my change in y, y2 minus y1, over my change in x, x2 minus x1. And I'm going to simplify that, and I get a fraction, -6/5, but we're just going to have to deal with that because slope is not always a whole number. Slope is that ratio, change in y over change in x. So now I have my slope, and I need to pick a point, and it does not matter which point I pick. I just need to pick one. So why did I pick the one I did? I don't know. I just picked it. It was the first one I saw. So again, substituting in for y, m, and x, solving for b, I get a y-intercept, a b value of 9/5. Going to have to handle the fractions. We're not making everything into decimals. Need to put it in fraction form. I get a b value, put that b value in with a slope value, and I have my equation of my line. Certainly not a very pleasant y-intercept, not a very easy slope to imagine, but my line is going down 6 and right 5, and I'm starting at the point 0.9/5. So it brings us up to why should we have some other things to solve our problems for us. The other thing I want to solve is I like this thing called point slope form. And in upper level mathematics, we often know a point and we know the slope, and we don't want to take all the arithmetic time to do slope-intercept form. If I look at the point slope formula, which I gave you, y minus y1 equals slope times x minus x1, I can use the same strategy of substitution. It's just now I'm substituting in my slope for m, and I'm replacing my x sub 1 with the x coordinate of the point and my y sub 1 with the y coordinate. And if I can add and multiply, I can simplify this equation. Subtracting -2 becomes +2. I can distribute the -3, and then using the subtraction property of equality, subtract 2 from both sides in the equation, and I can get an equation in slope-intercept form. I see I have a slope of -3. My graph has a y-intercept of 4, so my graph starts at 0, 4, and then I can go down 3, right 1 as many times as I want, and that line looks familiar to me, but the attack, the approach I used, is just a little bit different, subbing into a different equation, but still solving for y equals mx plus b. Just trying it again, just like last time, I kind of hid the slope from you. I can give you 2 points, and when I give you 2 points, I'm giving you the slope. So again, I calculate the slope, y2 minus y1 over x2 minus x1. We did this problem before, so I should get a slope of -6/5 again. But now I'm going to show you how I can pick that same point I picked previously, substitute my values into the point slope form, y minus the 3 equals slope, calculated -6/5 times x minus -1, and I can distribute and then add 3 to both sides of the equation and get the same equation I had before. Now, personal preference. Do you like slope-intercept form? Do you like substituting into y equals mx plus b, solving for b, and then having to write your answer? Maybe you do. Or maybe you like to just put it in point slope form and know that once you get your problem finished up and simplified, your answer is sitting there. You don't have to remember, oh yeah, I have to go back and replace the b value. I don't have an answer yet. Here, when you use point slope form, you already have your answer, your equation of your line. So I want you to kind of think about that. Upper level math, algebra 2, pre-calc, calc, we use point-slope form all the time. Probably the only place we use slope-intercept form, y equals mx plus b, is in Algebra 1, or when we want to use a graphing calculator and ask a graphing calculator to graph the line for us. So we do need to know slope-intercept form, but it doesn't have to be the only form. So moving on then, I did ask you to think about parallel and perpendicular lines. So parallel lines, if we're going to have two lines that are coplanar and do not intersect, then they're going to have the same slope, because it's the slope that keeps them from intersecting. If I have the same slope, I'm going to be able to have lines that are not going to touch. So in order to come up with that, a couple of things I had to do. Last chapter, why did we ask you to use your properties and solve for y? So that we could get an equation into y equals form, so that we could look at it and say that is the slope. So given a slope of 3/4, and now I want this new line to go through a totally different point, so I'll use my new slope, 3/4, my new point, and I went right back to y equals mx plus b for you, because you might like that form better. And I solved for b, and then I wrote my equation of my line, and I'm saying that even though it doesn't look like it, that line is going to be parallel to the given line. And if you look back at the original line, it did have a slope of 3/4. This line has a slope of 3/4, but this first line had a y-intercept of -3. This line has a y-intercept of -4 1/4. So they certainly don't start at the same point, but they do have the same slope. Therefore, they are not going to intersect. Lastly, we talked about some perpendicular lines. So up at the top here, I run through a perpendicular example. Much like the last example with parallel, I had to figure out what slope I was working with. So I took the very same line I had. So the slope is 3/4, just like it was last time. But now if I want to be perpendicular, we talk about the slopes being opposite, so meaning negative, and reciprocal. Turn that fraction upside down. So this time, just to prove that I can do it, I decided I would take my new slope, -4/3. I would take the point I want to go through, and I would use point slope form. Y minus y1 equals slope times x minus x1. I can multiply, distribute, add, and I get that the perpendicular line is y equals -4/3 x plus 2. And I hope you look at both of those lines and say, obviously they aren't parallel, because one of the lines is going down, it has a negative slope, and one of the lines is going up, it has a positive slope. So with those extra practices, along with everything else, the 10 problems I had you work on kind of go step by step. Which problem do we just kind of give you the information that you need? Well, numbers 1 and 2. We hand you the slope, we hand you the y-intercept. Certainly I would write my answers to 1 and 2 in y equals mx plus b form, because all I have to do is plug in the m, plug in the b, and I have my equation. My y's are always, in this example, -3/2 times my x plus 5/7. Pretty ugly y-intercept, but we can do it. 3 and 4 here are similar in that we need to know our slope, we need to know our y-intercept, but they're graphic. So number 3 here, I could calculate the slope, or I could look at this graph and say, well, I'm moving up 2, right 1. That's a slope of 2. Up 2, right 1. Up 2, right 1. I can see that the slope is 2. I'm also fortunate that I can see the graph crosses the y-axis at -1. That's my b value, so I can slip it right there into my formula. I have y equals 2x minus 1. I'm good to go. But on number 4, things aren't so convenient. The graph doesn't show us the y-intercept, and we can't guess at it. For my slope, I can go down 1, 2, 3, 4, right 1, 2, 3. I have a slope of -4/3. Now this is where point slope form can be helpful. If I choose to use the 0.15, I can go y minus 5 equals my slope times the quantity x minus 1. Use the distributive property, add 5 to both sides of the equation, and we can get that our line is y equals -4/3 x plus 19/3, 6 1/3 I would have had to guess, and I don't want to guess, that my y-intercept was 19/3. So moving on then, just demonstrating how I can use that point-slope form to my advantage when I'm given the slope and a point, not the y-intercept. I can run right into my point-slope form, substitute in my y1, my m, and my x1, and if I'm willing to distribute and use the addition property of equality, I can get the equation of the line, no messing around with solving for b and then having to remember to plug it in. Same thing over here. I have a point, I have a slope. That says use point-slope form. And you can see that I've plugged that in. I've distributed. I'm not changing that to a decimal. And then when I add 3 to both sides of the equation, I have to think about the whole number 3 as being 9/3, so I can add those together. Again, you're welcome to do that problem using slope-intercept form, but you're going to have to fight through the fractions. Lastly, to give us a little practice with parallel and perpendicular, and these questions typically come in groups of 2. We give you a question and then say, let's write a parallel line, let's write a perpendicular line. So much like everything else, we have to have the slope. I can see this problem has a slope of 4, so a parallel line will also have a slope of 4. It's not a surprise, I don't think, that I'm going to use point slope form, solve for y. I get y equals 4x minus 15. I'm very confident that these lines are parallel because they both have a slope of 4 and they have a different y-intercept. For the perpendicular line, I don't have to start over. If the original line has a slope of 4, my perpendicular slope opposite reciprocal, negative 1/4. Again, I'm going to plug in my point, y minus y1, slope x minus x1, do a little distributive property, do a little addition property of equality, and I get my perpendicular line. Number 8 is actually a special problem. An x equals line is a vertical line. So that means every other vertical line is parallel to it, and every other vertical line has to be of the form x equals. What do we want x to equal? Well, right there it says let x equal 5. So my parallel line is x equals 5. I can't do work to do this problem. I have to understand what's going on. Likewise, if an x equals line, vertical line, perpendicular to that would be a horizontal line. And horizontal lines are of the form y equals. What do they want y to equal? Y equals 4. There's my answer. The last two, again, I'm just reviewing the whole process. I'm choosing to use some lines that have some fractions in them. I pull out a slope of 4, plug in my point. You can see that I am able to multiply and add to get that. Perpendicular line, negative reciprocal slope. Plug in and again work with the fractions. Likewise, this last one, pull out the slope, 9/2. Parallel line has to have the same slope, and you can see I'm replacing my fractions in there, and I'm just very, very carefully multiplying and adding and not changing things to decimals. Decimals are approximate. These fractions are exact, and we want to be exact. For the perpendicular slope, negative 2/9. And I'm not saying that these are exciting to do every day, all the time, but we shouldn't be afraid of getting some answers that have fractions. So just a quick review, parallel lines are two lines that are coplanar and do not intersect. They have the same slope, but different y-intercepts. Perpendicular lines are coplanar lines that do intersect, and their slopes are opposite reciprocals.